Hello students and welcome to my channel Parikshit Physics. यो भिडियोमा चाहिँ मैले ICSE क्लास 10 physics को work, energy and power discuss गरेको छु and I have discussed everything from work, energy and power. In the next video I'll be solving numerical problems and other questions from Selina, त्यो ICSE को Selina book बाट 2025 को book बाट. Okay, let's begin. Your class ma first we will understand what is meant by work in science, physics, and then कसरी यसलाई मेजरमेन्ट गर्नु. त्यहाँबाट we will see the expression for work Fs cos theta, then special cases related to Fs cos theta, then we'll go to power and then we'll conclude this video with energy. Okay, now let's begin. हाम्रो daily language मा चाहिँ work is used for various activities such as writing, reading or eating. Read गर्नु हैन, बुकहरु पढ्नु, फोन चलाउनु हैन, क्यान्टिनमा बसेर मोमो खानु पनि यसलाई पनि कामै भन्छ हामी. तर फिजिक्स मा चाहिँ यो डेफिनेसन हाम्रो जुन चाहिँ अन्डरस्ट्यान्डिङ छ वर्क को यो काम लाग्दैन. फिजिक्स मा चाहिँ काम हुनको लागि पहिला त्यहाँ फोर्स हुनु पर्यो, बडीमा फोर्स अप्लाई गरेको हुनु पर्यो, अनि बडी डिस्प्लेस हुनु पर्छ in the direction of applied force. So basically work is said to be done only when the force applied on a body makes the body move in the direction of force. Okay, let's see this. You apply a force and the body moves. So A देखिको B सम्म body displace भयो. S is the displacement of the body on application of force F. So work done will be F into S in the direction of force. So basically the force र displacement चाहिँ तिनीहरु same direction मा हुनु पर्यो. Okay, this is one case for work done. Now let's see factors on which work done by a body depends. Work done by a body depends on अहिलेको लागि दुईटा factor. तीनटा factor हो but अहिलेको लागि दुईटा. First, it depends on magnitude of force applied. Because we know, W भनेको F into S. So it depends on how much force I apply on a body. And force apply गरेर what is the displacement produced in the body. It depends on F and S. So till now we have learned for a work to be done on a body, force and displacement, they must be in the same direction. But what if the force and displacement are not along the same direction? This case is also possible. It is not necessary that force and displacement are in the same direction every time. Let's see this example. A person is applying a force. So the direction of force is in this particular direction, F, and the load moves towards the platform. So this is the direction of displacement of the load. So clearly we can see that force and displacement, they are not in the same direction. They are making some angle which is greater than 0. Okay, so in this case, how do we calculate the work? How do we measure the work? So we go to the basics. Basics ma ke ho भन्दाखेरि force अनि displacement same direction मा हुनु पर्छ. Okay, so displacement त यो direction मा छ तर force त displacement को direction मा छैन अथवा displacement force को direction मा छैन. So what I do in this case is I will find the component of force which is in the direction of displacement. So for that, let me write this as A, this as B, and this as C, and let me draw a perpendicular. So this is my right angle triangle. So in my right angle triangle, hypotenuse is force, base is BA, which is S. Now I have to find component of force which is along BA. So I use this trigonometry. Cos of theta is base, which is BA, divided by hypotenuse, in this case, which is BC. And we know BC is F. So if I take this F over here, I get BA as F cos theta. So base is displacement. Yes, base is also F cos theta, component of force in the direction of displacement. So in that case, work done, I go to the basics, force and displacement in the same direction. S is my displacement, F cos theta is my force. On rearranging, I get this as Fs cos of theta. So this is my expression. So when force and displacement are not in the same direction, okay, work done will be F into S cos of theta. This F is force, S is displacement, theta is the angle between F and S. Now we have three factors on which work done by a body depends. First is magnitude of force, second, displacement produced by the force, and third, angle between force and displacement. Now let us see three cases for the angle between force and displacement. First case is angle between force and displacement 0 degree. Second case, the angle between F and S is 90 degree. And the third case is the angle between F and S 180 degree. Let's go to the first case. Theta is equal to 0 degree भनेको force र displacement same direction मा छ. If this is the direction of force, okay, displacement is also in the same direction. Angle is 0 degree. In that case, work done will be Fs cos 0, and since cos 0 is 1, work done is simply F into S, and here positive work is said to be done. Let's see an example for this. A ball which is dropping from a height, okay? A ball drops from a height because of gravity. Gravitational force acting on the body, on the ball over here is mass of the ball into g, which is the weight. Weight is the force in the downward direction, and the body is getting displaced. It's dropping from a height A to B. So displacement is in the downward direction, force is in the downward direction. They are in the same direction. So work done is, in this particular case, no, work done will be force into displacement is height h, mg is force into h. So work done by gravity when the ball is falling is mgh. It's a positive work. Next, yahanira some persons are pushing this car, okay? They are applying force and the car is moving in the direction of force. So here again, angle is 0 degree and work is positive work, F into S. Next case is when angle is 90 degree. Force your direction ma छ भने displacement will be perpendicular to it at an angle of 90 degree. Or force your direction ma छ भने displacement will be at an angle 90 degree. Or it can also happen that force is in this particular direction, displacement is at this direction. Again, the angle is 90 degree. Example, a person is carrying load on his head and he is moving. Okay, so force of gravity is in the downward direction and his movement is normal to it, perpendicular, normal to it. So angle over is 90 degree between force and displacement. So in this case, work done, okay, by gravity in this particular case is 0 because the angle is 90. One more example. I have a nucleus, forget about this omega. I have a nucleus, let's say, and electrons, they revolve हुँदैछ. So यहाँनिर एउटा towards the center एउटा force लाग्छ जुन चाहिँ हो मेरो Coulomb's force, and that is my centripetal force. So centripetal force is towards the center, and body को displacement, instantaneous displacement at this instant, सानो displacement हेऱ्यो भने, okay, at a very short interval of time, it will be tangential. Body revolve भएर यहाँ पुग्दाखेरि centripetal force is towards the center, सानो displacement is tangential. यहाँनिर आइपुग्दाखेरि centripetal force towards the center and displacement tangent. Displacement is tangential. And we know यो त रेडियस भयो नि त हैन रेडियस र टेन्जेन्ट इट्स 90 degree सो मेरो सेन्ट्रिफ्युगल फोर्स र डिस्प्लेसमेन्ट इज एट 90 degree here also 90 degree here also 90 degree so everywhere F and S will be always 90 degree so work done by centripetal force in a circular motion is 0 so when work done is 0 बडीमा कामै गरेको छ भने यो बडीको एनर्जी इन्क्रिज हुँदैन एनर्जी इन्क्रिज नहुनु भनेको यो बडीको स्पिड चेन्ज हुँदैन ओके सो टिल नाउ वी हेभ लर्न अबाउट कन्डिसन्स फर जिरो वर्क हुनुको लागि के हुनु पर्यो एउटै कन्डिसन हामी पढ्यो जस्तै फोर्स पनि छ डिस्प्लेसमेन्ट पनि छ तर एंगल त 90 डिग्री भयो अरे एफ र यसको इन द्याट केस वर्क डन इज 0 अहिलेसम्म त्यो डिस्कस गर्यो प्रिभियस स्लाइडमा okay so for zero work to be done either angle between the applied force and displacement should be 90 degree or the displacement should be 0 like force पनि छ हैन तर displacement नै छैन we are pushing a wall यहाँनिर he is applying a force and the wall is not at all moving displacement s is 0 and what is work is f into s if this s is 0 f into 0 which is 0 work is done so two conditions are angle should be 90 degree or displacement should not be there example person pushing a wall now let's talk about unit of work is a physical quantity it must have a unit okay remember work is f into s into cos of theta यसको त unit छैन it's a number value f ko unit newton displacement ko unit meter so newton into meter bhaneko unit of work which is called joule so 1 joule bhaneko 1 newton into 1 meter so euta body ma you apply 1 newton of force and the body gets displaced by 1 meter in the direction of force. In that case, work done is said to be 1 joule. Okay, bigger units of work, kilojoule, where 1 kilojoule vaneko 1000 joule and 1000 vaneko 10 to the power 3 joule. 1 megajoule vaneko 10 to the power 3 ले बढ्छ that is 6 joule. एक को पछाडि 6 वटा 0 1 gigajoule भनेको 10 to the power 9 joule CGS unit of work is erg अनि 1 erg भनेको CGS unit of force which is dyne into CGS unit of length which is displacement which is centimeter so 1 erg is 1 dyne into 1 centimeter so on applying 1 dyne of force, a body gets displaced by 1 centimeter in the direction of force. In that case, work that is said to be done is 1 erg. 1 erg of work is done. And now work is a scalar quantity. In physics, we have quantity, we have vector quantity, and then we have scalar quantity. Vector quantity भनेको त्यो quantity जसको magnitude as well as direction मलाई important छ and it follows vector law of addition. Scalar quantity भनेको त्यो quantity हो जसको मलाई magnitude भए पुगिहाल्छ direction doesn't make sense and it follows scalar law of addition. So work is a scalar quantity. मलाई direction सँग मतलब छैन work को direction छैन okay यसको magnitude खाली छ magnitude is enough to specify work. Now we come to power. Power is the rate of doing work. Rate of doing work भनेको 1 second मा हामी कति काम गर्छ. Okay, how much work is done in 1 second? That is our power. एकजना मान्छेले 1 second मा 10 जूल काम गरे रे. अर्को मान्छेले त्यही 1 second मा 5 जूल मात्रै काम गरे रे भनेपछि यसले ज्यादा काम गर्दैछ. So power of this is more. And how do we calculate power? To calculate power, total work done divided by total time taken to do that work. That is power, work done by time taken. Unit of power, work done ko unit joule, time taken ko unit second. So joule per second, and that is called watt. So 1 watt is 1 joule per second. Okay, 1 watt is 1 joule per second. So 1 joule काम 1 सेकेन्डमा गर्यो भने कुनै पनि मसिनले त्यो मसिनले 1 watt power deliver गर्छ. Now there is another expression for power, and that is force into average speed. How do we get this? We know power भनेको work divided by time, total work. Total work भनेको force into displacement divided by time, and force into S divided by T. Okay, I'm talking about constant force, which does not depend on time. So force into total displacement by total time, this is my average speed. So my power is nothing but force into average speed. And here again, power is a scalar quantity. Bigger units of power. Kilowatt, 1 kW. 1 kW भनेको 10 to the power 3 watt. 1000 watt भनेको 1 kilowatt. Megawatt, 1 MW. 1 megawatt भनेको 10 to the power 6 watt. 1 gigawatt, GW. 1 gigawatt भनेको 10 to the power 9 watt. Similarly, smaller units of power, 1 milliwatt, 1 small m capital W. 1 milliwatt भनेको 10 to the power minus 3 watt. 1 microwatt भनेको 10 to the power minus 6 watt. CGS unit of power, erg divided by second. And 1 watt is relationship between SI unit of power and CGS unit of power. 1 watt is 10 to the power 7 erg per second. Okay, our total mechanical engineering, we have another unit of power, that is horsepower. Our 1 horsepower भनेको 746 watt together, that constitute 1 HP. किलोवाट में हेर्दाखेरि यसलाई 1000 ले डिवाइड गर्यो भने त किलोवाट मा आइहाल्छ, which is 0.746 kilowatt, and that is 1 horsepower. Next, final, energy. कुनै पनि बडी ले काम गर्नको लागि, okay, कुनै पनि बडी ले वर्क गर्नको लागि, it must have energy. Energy छैन भने, if it does not possess energy, work is not said to be done. So the capacity to do work is called energy. Whenever you do work on a body, energy of this body increases. Whenever work is done by the body, energy of this body decreases. So work and energy are related. And since they are related, unit of work and unit of energy, they are same. SI unit is joule, CGS unit is erg, and energy is also a scalar quantity. Okay, the final value for theta that we need to study is theta being 180 degree. 180 degree भनेको force यो direction मा छ भने त्यसको ठीक opposite मा चाहिँ displacement हुन्छ. So that the angle is 180 degree. So force and displacement are in opposite direction. So in that case, work done will be Fs cos of 180. Cos of 180 is minus 1. So Fs into minus 1 is minus Fs. Negative work is done. Okay, in this particular case, negative work is done. What is an example? Suppose we have a person. He throws a ball upward. Okay. So in that case, what happens? This ball, man, there will be a force of gravity in the downward direction, and the body is getting displaced in the upward direction. So angle is 180 degree. So in this case, work done by gravity when the ball is thrown upward is negative. One more example, same ball if it kicks, what happens? The ball will move in the forward direction, and we know there is a friction which is opposing this motion. So friction and displacement, they are in the opposite direction, again 180 degree. So the work done by this force of friction is always negative. So bigger units of power are watt hour and kilowatt hour, where 1 watt hour is can be expressed as 1 watt into 1 hour. 1 watt is 1 joule per second, and 1 hour is 60 into 60 seconds. So when we multiply, we get 3600 second joule, because second and second gets cancelled. 1 watt hour is 3600 joule. 1 kilowatt hour is 1000 joule per second into 60 into 60 seconds. Second gets cancelled, so it is 3.6 into 10 to the power 6 joule. Smaller unit of energy is electron volt, where 1 electron volt in terms of joule is 1.6 into 10 to the power minus 19 joule. Okay, now what are the differences between work, power and energy? First is work is the product of force and displacement in the both are in the same direction. Power, it is the rate of doing work, so power is W by T. Energy is the capacity to do work. Okay, power has a time dependence, so it depends on time, whereas work does not depend on time. Energy also does not have time dependence. SI unit of work is joule, SI unit of power is watt, and SI unit of energy is joule. Numericals related to this chapter will be done in the next video. Thank you for watching this video.